The outputs of logical and relational operators are logical values. They're a special type of data in Octave. Octave treats logical values differently from numerical values. Using logical values as array indices, for example, can allow you to extract elements of an array which meet certain criteria. Up until now, I've only used positive integers as array indices. I can get a number that's in the third row and fourth column of an array by using the indices 3, 4. Octave starts counting rows and columns with 1, so I haven't been able to use 0 as an array index. This isn't true if I use logical values as array indices in Octave. If the index is a logical value, 0 is a legitimate array index. Since in logical terms 0 corresponds to false, sending a logical 0 as an array index means, in some sense, that you don't want that value. It's false and doesn't meet whatever criteria you're using to select array elements. Any logical value other than 0 corresponds to true. To Octave, this means that the array element meets your criteria, and Octave will return that value. Logical values can be used as array indices to access selected array elements. There are two main ways to create logical values. As I showed you in the previous video, relational and logical operators both return logical values. You can also create logical values with the logical command. As an example, I've created an array IND containing these numbers. I can convert these numbers to logical values by typing logical of IND. According to Octave's rules for logical variables, any number that's not 0 is considered to be true, and Octave returns a 1. Any value that is 0 is false, and Octave returns a 0. So I get this array as a result of this command. Now suppose I have an array A containing these values. I can use the logical values here to access specific elements of the array. So if I type A of logical of IND, this logical array of 1s and 0s is used to select elements of the A vector. Octave's interpretation of this is that you want to extract the elements of A that correspond to true indices. So the values 2, -4, 7, and 5 are returned. All of the other elements have 0-valued indices, which Octave feels that you don't want, since they correspond to a false condition. The important thing to keep in mind here is that Octave treats logical values fundamentally differently from numbers. The number 0 is not a legitimate array index, but the logical value 0 is. Just to illustrate how the results look in Octave, I'll do a couple of quick demos of logical array indices. I'll create a vector of uniformly distributed random numbers between 0 and 1 by typing x equals rand of 1, 7 and pressing enter. Next, I'll round these numbers to the nearest integer by using the round command. x_int equals round of x. I end up with an array containing only 1s and 0s. These can be converted to logical values with the logical command. So x_logic equals logical of x_int. Any non-zero values become logical 1s, and 0 values become logical 0s. There is a difference between the 0s and 1s in the x_int array and those in the x_logic array, even though they look exactly the same. To see the difference, use the isLogical function. I'll type isLogical of x_int. A 0 is returned, indicating that these values are ordinary numbers. Now, if I type isLogical of x_logic, I get a 1. So the x_logic array contains logical values. This is also apparent in the workspace window, where the x_logic array is indicated as being a logical array. This difference is important since logical values are fundamentally different from numbers in Octave. For example, I can't use x underscore int as defining elements in the original array of random numbers. If I type x of x underscore int, I get an error. However, x underscore logic works perfectly well as indices to the x array. If I type x of x underscore logic, I get back the elements of the x array corresponding to the indices that have values of logical 1 in the x underscore logic array. This really just corresponds to the values of the original x array, which rounded up to 1, which are just the values that are greater than 0.5. Since logical and relational operators automatically return logical values, they're really easy to use to extract elements of an array that meet certain conditions. You can apply the logical and relational operations to an array. The operators will return an array of logical values which indicate which elements of the array meet the logical or relational criteria. Ones are in the locations corresponding to elements that meet the condition, and zeros are in the locations where the elements don't meet the condition. This logical array can then be used to access the elements of the original array that meet the condition. For example, I have this array B in my workspace. The relational operation B greater than 0 returns an array with 1s in locations to positive values of B, there and there. If I use that array of 1s and 0s as an argument to B, I extract the values here and C becomes 1 and 5. Now I'll do something similar to the last demonstration, but use relational operators. Recall that the last time I created an array of random numbers between 0 and 1, and then used a rounding process and logical values to determine which elements of the original array were greater than 0.5. Now instead of my previous approach, I'll just type x of x greater than 0.5. The arguments to the array are defined by the relational operator x greater than 0.5. This operation returns a logical array that has 1s where the values of x are greater than 0.5 and 0s elsewhere. When this is used to access elements of x, the returned values are the elements of x that are larger than 0.5. Logical operators can be included in these expressions. For example, to get the values of x that are between 0.25 and 0.75, type x of x greater than 0.25 and x less than 0.75. So the values of x that are both greater than 0.25 and less than 0.75 are returned. There's a command, find, which also allows us to access arrays which meet certain logical or relational criteria. Find returns the indices at which non-zero array elements occur. This is particularly useful if the array sent to the find command is logical, and probably even more useful if logical or relational operators are used to generate the array. As an example of this, I can create a row vector of 5 uniformly distributed random numbers between 0 and 1 with this command. This command finds the values in that array that are larger than 0.5. The find command returns indices where this condition is true, and using those indices as an argument to D extracts the values that are true or returns the values that are greater than 0.5. To use the find command to determine the indices of the X array that are between 0.25 and 0.75, the syntax is similar to what I used before. This time, though, I'll define a variable named index, which contains the indices of the appropriate values of x by typing index equals find of x greater than 0.25 and x less than 0.75. Then I can get the appropriate values by typing x of index. Of course, as before, I could condense this into one command by typing x of find of x greater than 0.25 and x less than 0.75. Using logical and relational operators to extract desired elements from an array is a form of decision making. An even more powerful decision making tool is the if structure, which is the topic of the next video.